color is being formed. Let me zoom it. So when the part comes, it gets located, the strip gets located at these three pilot pins, right? So by these three pilot holes, pilot pin comes and locate it, and then this small form happens, right? Now after this, we go to the next station where we do the trim, outside trim, and those four small holes. Why we do four small holes? Because otherwise we had to we because we are flanging it up, it's not possible to do this by cam here, so we have to do it before we flange it up, right? So before flanging we had one idle. Now here we are flanging it up. All the area which is shown by magenta color, we are flanging it up, right? And this is the only operation happening here, right? Now let me rotate it little bit more so that you guys can see what is happening here. All right, you also see how the part is now connected to the carrier through small connectors. You can also notice why we have that oblong banana hole, because that is what helps you if the carrier connector needs some stretching, that banana shape cut will let it happen. Now in this station we are doing the flange down, and in this station we are doing restrike. So we are restriking all the surfaces, important surfaces, to meet the surface requirement, surface and flatness requirement, right? In this station we are doing cam piers, that's operation 10. As you can see from this side, these three holes we are doing cam piers. We will have one big cam over there, and in this station we are doing all the hole piercing, all those holes, and the last one we are doing cut off and the part gets out, right? So this was the very first prelim strip layout, and when we completed it, we had a review with our customer, and those review points we incorporated in the next and final strip layout. So now some of the areas here, like I already told you why we use banana cutout, because had it been solid it would have caused some problem in stretching. Because of banana shape cut, it will be bit easy to pull it, right? Okay, so that is some information on the strip layout, and here is the review presentation what we had with our customer. Not many reviews, so they wanted to add pitch notch. Okay, now let me tell you what is pitch notch. Pitch notch is nothing but it helps you to give a feedback to press PLC. So when the feed progresses, previously cut notch get stuck with the pitch notch sensor. That sensor is connected to the press PLC, and it will give you a signal, okay, yes, this is moving good, this is in position. There will be one more sensor which is end of feed sensor. That end of feed sensor is at the end of the strip. So when after end of each and every stroke, when the part touches that sensor, I mean strip, when the strip will touch that sensor, it will give another message to the press PLC that yes, not only the coil passed came in the correct position at the time of pierce, but also it came to the correct position at the final station. Means there is no buckling, right? No buckling happening in the strip, because these dies run at very high SPM. This will run at 45 SPM. If we don't have anything over there, then this will be a problem. Apart from that, we had couple more stations, like add one more idle station, move some punches here and there, right, and reduce the coil width. So this was the review feedback. Now we are taking you through the final approved strip layout. Let me open this now. Okay, okay, so let me hide the bolsters. Okay, as you can see, we have done some changes here, and so instead of three piers in the first station, we only made two pilot piers and one pitch notch. All right, and then we have done third pilot piers over here, and all three pilot piers are of same size now. These are 12.8 millimeter in diameter, so that a half-inch pilot pin can go. 12.7 millimeter diameter pilot pin can go. So we are doing some trim over here, and over here form, over here trim, right, and over here we are doing this for a small diameter hole. This one remains idle, and then next one we do flange up, and next one flange down, and after that we have destroy. Then we have cam piers. Yeah, we have cam piers over there. Then we have at this station all the piers, and that one small round hole we do at this station, and we also do the cutoff at this station. So the part is done in 13 stations. Previously we have 12 stations, now we have 13 stations. Let me show you the 2D drawing, 2D of strip layout. It has more information over here. So okay, as you can see all these information, so you can see the start line as well. A start line is a line when we feed the coil first, it will come and stop there, and we have a self collapsible pin which is spring loaded pin over here, which will stop the first feed, and then when you push it, the pin will go down and it will can move easily, right? So you can see we have 12.8 millimeter pilot pins, and you can also see we have in the very first station we have Ford logo as well as part number. So you know we have to stamp the part number as well, we have to stamp the date of production as well, right? And we have Ford stamp as well over there. So as you can see we have all these three informations here. So now it mostly remains the same what we had in the very first, not very much different. We moved here and there, right? So the first station it gets piloted over there, and then we have this third pilot. Next station we have three pilots, and next we have three pilots, right? So as you can see the carrier width on the top end side 8.4, bottom size 10 millimeter, right? This is the form So this is the form here, right? And then we are doing the stream over there, and then we are doing piercing. So basically it's same what we had in the 3D. We also have 2D prepared with us. So 2D we can take a printout, right? And here it is, right? And all the tonnage at each and every station. So you can see 271. So we were able to reduce the coil width by 2 millimeter. Correct? It remained almost same 44.5%. So that's what our strip layout is. So we had discussed one part simulation and strip layout both. I will discuss one more part which is very complicated, the tunnel which I had shown in my LinkedIn post. I'll discuss its